What is the sum to n terms of the following series? Let us begin. So here we have a series whose first term is 1 cube. Then we have the next term given by 3 cube, followed by 5 cube and 7 cube. And this continues all the way up to n number of terms. Now to find out the sum of this particular series, we need to figure out what is the nth term of the series. So we'll suppose that let Tn represent the nth term of the series. Now our goal will be to figure out what is the nth term of the series. So if we consider the first term, we have 1 cube. But let's consider only 1 here. We are dropping the cube here. And similarly from the second term, we have 3 cube, but we're dropping the cube part. So we have 3, then we have 5, then 7. Now clearly, these terms are going to be in arithmetic progression. So if they are in arithmetic progression, then the first term, which is 1, and common difference, which is 2, this is going to help us define the nth term of the sequence. So that's given by a plus n minus 1 times the common difference, d. Now this is going to be equals to 1 plus n minus 1 times 2. So we have 2n minus 1. Now this is the nth term of the sequence 1, 3, 5, 7. So what we'll do, we'll take that nth term 2n minus 1 and we're going to cube the value. And this is going to give us the nth term of the series. We can verify that if we choose n to be equals to 1, then the first term is going to be 2 times 1 minus 1. So that's 1 cube. If we choose n to be equals to 2, so we have 2 times 2, that's 4. 4 minus 1 is 3. So 3 cubes. So that gives us the third term. And also we can find out the rest of the terms. Now let's expand 2n minus 1 whole cube. So that's going to give us 8n cube. Then we have negative 12n squared plus 6n minus 1. Now to find out the sum, of the series 1 cubed plus 3 cubed plus 5 cubed all the way up to n terms. So this can be written in a compact form as summation tk, where k goes from 1 to n. So here tk represents nothing but the nth term, but we're changing the index from n to k. That means we now have to find out summation of this expansion, but we are going to replace n with k. So we have 8k cube plus 12k squared plus 6 times k minus 1, right, where k runs from 1 to n. Okay, now we further expand this. So we have 8 times summation k cube. Now here we have pulled out the 8 because 8 is a constant. And we have k going from 1 to n, minus 12 multiplied to summation k squared, where k runs from 1 to n, added to 6 times summation of k, where k goes from 1 to n, minus we have summation of 1 with k running from 1 to n. Okay, let us further simplify. Now, summation of k cube, this is simply, so let's note down the formula, summation of k cube, where k goes from 1 to n. Now this is the sum of the cubes of the first n natural numbers. That means 1 cube plus 2 cube plus 3 cube all the way up to n cube. And we have a standard formula for this. This is given by n squared times n plus 1 whole squared divided by 4. We can use this value. We have 8n squared times n plus 1 whole squared divided by 4 minus 12. Next we have summation k squared. Now summation k squared means we have summation k squared, where k runs from 1 to n. Now this is simply the sum of the squares of the first n natural numbers. So 1 squared plus 2 squared all the way up to n squared. Now that's going to give us, we have a standard formula for it. We have n multiplied to n plus 1 times 2n plus 1 whole divided by 6. So let's use this formula. So we have n multiplied to n plus 1 multiplied to 2n plus 1 whole divided by 6. Okay, then coming to the third term, we have 6 multiplied to summation k. Now what is summation k? That is the sum of first n natural numbers. And that's going to be given by n times n plus 1 divided by 2. Let's use this value. We have n multiplied to n plus 1 divided by 2. Minus, now summation of 1 simply means that we have 1 added to 1 added to 1, and this is happening n times, n to n terms, to n number of terms that this is happening. We'll come back to that in the next step. So now we have 4 times 2, that's 8. So this gives us 2n squared multiplied to n plus 1 whole squared, minus the 6 times 2, that's 12. So we have 2n multiplied to n plus 1 times 2n plus 1. The next we have 2 times 3, that's 6. So we get 3n multiplied to n plus 1, minus the 1 plus 1 plus 1, that's happening n number of times, that's simply n. Okay, so when we simplify this, we are going to get n squared multiplied to 2n squared minus 1. I'm going to leave the algebra part for you to verify that it's indeed n squared, 2n squared minus 1. So this is going to be the sum of 1 cube plus 3 cube plus 5 cube all the way up to n terms.